Thank you, Daniel. This is called Assessing North Carolina's Woody Biomass. And I used to call it Accurately Assessing North Carolina's Woody Biomass. There's really no way of accurately assessing it, so it's kind of a misnomer. And I was putting my foot in my mouth every time I did it. But it's probably one of the more accurate ways, or at least inaccurate ways, of assessing North Carolina's woody biomass supply out there. And I've attributed this to both me and Chris Hopkins, this is really the brainchild of Chris Hopkins a number of years ago. And I'll go into a little bit of history as to how this methodology developed. There's a number of different ways and a number of different groups that are out there that go out and try to do an assessment of what's out there in the landscape with woody biomass. You might be familiar with the, help me out, with the Biosat in University of Tennessee. Did I say it correctly? And they use one methodology. There's a number of different websites that are out there online that you can access this. We try to use a methodology that applied, is this going to not work for me? Okay. We tried to apply it so that we're actually using some sort of a spatial model of where the forest types are in North Carolina and in the surrounding states as part of this analysis, okay? So it's a little bit different, and hopefully, this is kind of a GIS geeky sort of lecture here, but hopefully you'll see where we're going with this and how we end up using this to serve the biomass industry that's burgeoning in North Carolina. So first thing we're going to do is just briefly, and I think Helene did a much better job of describing what's going on out there in terms of the landscape, and you'll be hearing more about this from Dennis and other folks too. Some of the drivers for why we need to be able to assess how much woody biomass supply we have. And not only that, but what's also the drain out there? Who are the competitors for this stuff, okay? So if you're a mill that's looking to build here in North Carolina, well, not here in North Carolina, but 2 states down in North Carolina, you might want to know what the competition looks like out there in terms of supply and demand, okay? We're going to be looking at this 2 different models that we apply. One is kind of a statewide model, and that really is based on some sort of a gradient model, where how it changes as you move across the landscape. And then we're going to, a lot of our clients look for is a site-specific model. The statewide gradient gives you more or less regional ideas of where might be good places to site a facility. And the site-specific, we really hone in and give you some more detailed information on that. Okay, so just real quickly, here's some of the current and developing whole tree chip demand. We're talking about whole tree chips. We're talking about things like tops and limbs, logging residues, stuff that may actually come out during land removal operations, which is not sustainable, but it's still there out there as development takes place. All these circles are just the folks who are out there. Those are their wood baskets. So for instance, this guy right here, that red dot, that might be their wood basket, a 50 or 60 mile swath around them. And notice that's not a perfect circle, that's travel distance, and that's one of the approaches that we use that's a little bit different from a lot of other folks. We actually go out and look at what the travel distance is going to be so that they can really get a better assessment as to what their wood basket's going to look like. So we've got all these different folks who are out there. Biomass power facilities generating electricity. Got combined heat and power companies that are out there. Pulp mills even use a lot of these in-woods chips or these whole tree chips to provide power, steam power to run their mills. So it's used in a lot of different areas besides just energy production for generating electricity. It's used in a lot of other process type plants as well. If we just looked at what's going on in terms of who wants logging residues, okay, the biomass energy, well, first of all, this is kind of a confusing looking chart, so you got to train your eyes to look at it for a second here. Red represents hardwood, green represents softwood, okay? These more maroon looking colors over here are what's the current whole tree chip demand, okay? These lighter, or actually I guess they're darker green, are the current softwood whole tree chip demand, okay? These more brighter colors are what the potential demand could be if everybody got their way, okay? In that previous picture here, I drew a box around an area of North Carolina and part of Virginia and a little bit of South Carolina, and then I assessed what's going on out there. What if all these companies who are knocking on the doors of North Carolina, South Carolina, and Virginia and saying, we're thinking about putting a facility in here, what if everybody got their way, all right? What would happen? Now, that's probably not going to be the case, but what would happen? Well, just as of last October, this is where I put this data set together from, that it would change our, just the woody biomass energy use from 5.5 million to more than double, okay? And that would be a huge increase in the demand of just logging residues, all right, if everybody got their way. So really what you're looking at is here is the current, what the potential could be for both softwoods and hardwoods as a result of biomass energy. Pellet mills, not a huge change in comparison to being used for biomass energy, but still, 3 times as much almost. These two little cones here on the far right are showing you what would happen, or this is the actual current supply of our regional inventory within that square of logging residues on an annual basis. That's more or less how much we produce on an annual basis, okay? So you can see the difference right here. Oops, right? We've got a millions and millions of tons difference between the potential demand and what the actual amount that we're generating is. So there's a real need for understanding what the woody biomass supply is out there. Same thing goes for our pulpwood chip demands, okay? These are just all pulpwood using facilities. And again, we've got kind of the same story going on. Now, I don't know if you gleaned from what Helene was saying is that the pellet industry uses not only logging residues, but they're also big users of roundwood, okay? They're going out there and they're looking for hardwood, pulpwood-sized material. And they're chipping that up and they're making pellets out of it. In fact, they're looking at that a lot more than they're looking for logging residues. Right now, as of last October, that was the current demand. And if everybody got their way, that could almost quadruple, at least 3 times as much if all the pellet mills got built that say they're going to get built in the area. Pulp mill, we don't really see a whole lot of change in what's going to happen down the road. Current hardwood use, it's dropped considerably. Current softwood use doesn't look like it's going to be growing a whole lot in the future. So, but again, there's a huge amount of pulpwood that's actually going to be looked at in terms of what the supply and demand can give us in this region here. These are just the pulp mills that are in the area. I think I got a couple of outliers. He doesn't really belong. But there's a lot of pulp mills in the region that are requiring a lot of that pulpwood. Around 2007, Chris Hopkins was put together a grant for, as a result of this RPS that Dennis, you'll be hearing more about it from Dennis tomorrow, was the Renewable Portfolio Standards. And a lot of the energy companies were concerned in 2007 because they had to start using renewable energy sources as part of their energy production as a result of that renewable portfolio standard in 2007. So Duke Power contracted Chris Hopkins to develop a woody biomass analysis around their 7 coal fire plants in North Carolina and South Carolina. And so Chris and I put our heads together, and I did the GIS stuff, and he had really good working knowledge of FIA data. So we put our heads together and developed a methodology that would, the cornerstone would be to use the spatial distribution of the land use types of hardwood lands and softwood lands. and be able to use that. Now, hopefully you'll be able to see how that works in here. So we've been doing this since 2007, and it's going strong. As of 2010, we created actually a service center within Extension Forestry, and called it Fiber Analytics. And we've got a number of people who are helps pay the bills for a lot of the things we're doing. So it is a for-fee service that we do these analysis for. Not a huge fee, but a fee nonetheless. Oh. Okay, come on. There we go. So what do we do? Well, one is like I said before, the backbone of the analysis is spatially derived estimates of biomass at either what we call the state level gradient. So as you're moving across the state, you can see changes in the amount of woody biomass, and that's good. You know, if you're dark red, means there's a lot of logging residues. Okay, that's not bad. You know, it gives you a good visualization as to what's going on. Once you identify an area of interest, then we can narrow it down and do these point-centered analysis. Okay, and I think if you look at the difference between some of these analyses across the state, you'll see why it's important that you really hone in on a particular area. Simply from travel distance alone, right, you can see there's a huge difference between the mountains of North Carolina. These are all, I believe, 100-mile travel distances from the green dots in the center. Okay, so you have a whole lot less supply area within 100 miles in the mountains than you do here and here in the coastal area. So that's important, and so that's we provide that information for both people. I mean, for all groups. If you look carefully too on here, you can see the brown, the dark brown. That's hardwoods. Those are hardwood forests. The light green colors, those are softwood forests. So spatially distributing the land use type out there and attributing what the woody biomass possibilities are in those areas is very important. Okay, so right over here you can tell there's not a whole lot of hardwoods compared to this region here. Okay, not a whole lot of hardwoods in this whole area compared to up in the mountains. So we use a ton of data. I'm not going to dwell on that, but I do want you to be aware we heavily rely on FIA data, which produces the U.S. Forest Inventory and Analysis Program produces these data from these inventory plots that are gone back and remeasured at periodic intervals. And we also use this data called the Timber Products Output, or TPO data. Are you familiar with that? Is anybody here not familiar with it? Okay, TPO data is really a survey, an industry survey. Every other year they contact all the industries in the area and say, where, how much wood have you purchased? You know, what type of wood was it? Where did you buy the wood? What counties did that wood come from? They go back, they backtrack all that information. They come up with assessments of what the removal rates were for saw timber and pulpwood and all this other stuff on a county by county level. Okay, so it's a pretty good piece of information. It's and another piece of information that we've started to use in a couple of our projects is the NASS data, or the National Agricultural Statistics Service. Comes up annually, tells you how many tons of or bushels of corn were harvested, grown and harvested on an annual basis, on a county by county basis too. Very, very important information if you're looking for other sources of biomass besides just wood. Okay, so how do we do this statewide gradient model? All right, this right here represents all the wood, the hardwood forests. Okay, and it comes from this data set called the National Land Classification Data Set. It unfortunately only comes out about every 5 years. So the newest data we've got that we're working with is 2006. It's already 7 years old. Okay, and so that's a little bit of a problem. What we do is, if you notice, you got this white blotch missing right here. Does anybody know what that is? What does that look like to you? Smoky Mountains National Park, okay? There's a lot of white blotches that have been removed because we remove all reserved lands from that data set, okay? So that's a data set that's just showing on a 1 mile square grid where all the hardwood stands are, okay? This TPO data, we're just using a hardwood logging residue example for this, okay? But we do the same process for pulpwood, hardwood and softwood pulpwood. We do the same process for agriculture products and anything that we have a data set for. But we have logging residues from that timber products output that's identified every other year. And that's on a county-by-county basis. So what we do is we take this TPO data and we spread it out, okay, across the amount of forest land in this county, and in this county, and in this county. So then we end up with a map, basically, that's telling us how much logging residues are found and where they're found, okay? Now, when you harvest, all the harvesting in that county may actually be taking place right there. We don't know that, all right? So we have to spread it out across all the hardwood forested areas in that. We just don't have that kind of information like Washington does, where they know where all the harvests take place every year. So I end up with this map here that's showing me where all the logging residues are in the county for hardwoods, and gives me some sort of an estimate of how much each one of those raster cells has in terms of logging residues, okay? Then what we do is we apply this, what we call a focal sum to it. So let's pretend I want to find out what the amount of logging residues I can obtain at that point if I went out 10 miles around it and added up all those pixels, okay, that are inside that 10-mile area and summed them all up and stuck them in that point, okay? Then I moved over to the next point, just to the right, and I did the same thing again. Moved over to the next point, draw a circle, add everything up inside that circle, and just keep moving over. That's what a focal sum does. It focuses on a point, draws a circle around it, and then it adds up everything inside that circle and applies it to it. So this is the result of a 10-mile focal sum, okay? And so at any given point, if I looked at what the value was of each one of those little pixels in there, it'd be telling me how many tons of logging residues I could find on a 10-mile radius around it, okay? Do the same for 20 miles, 30 miles, 40 miles, 50 miles, and 60 miles. And these values are not the same. Obviously, these are going to be much, much larger values because I'm going out further, 60 miles around a single point, adding everything up, and applying it to that point, okay? So, but just so you can see, we're doing that at these various levels. We get a spreadsheet and we add all those columns up. So this is the hardwood logging residues at 10, 20, 30, 40, 50, and 60 miles. That's one point on the map, okay? So if I went out 10 miles, that's how many tons of logging residues I should be able to find. That's if I went out 20, you can see that gets larger and larger. It's a kind of an exponential curve. Okay, we try to fit these curves as best we can to a model that describes it, and green tons equals the intersect times the distance to by some sort of exponential coefficient of slope, and all we're doing is we're trying to solve for A and B, and we end up using these fancy Excel formulas right here. We end up with a model, what we call our alpha and beta models, okay? Sounds pretty ridiculous, but we put that back into a spatial format, and now, why are we going through all this process? Because we're trying to develop a really cool and interesting and flexible model for folks. So we end up with these alpha beta files, okay? And it's really cool because all we have to do now is plug in a formula. If I want to know how many logging residues are at a 35-mile point, at 35 miles at any given point, let's say that's as far as I want my trucks to go. Okay, I only want them to go 35 miles. I can plug that into this formula where it's the hardwood alpha file times 35 raised to the beta file, and voila, it gives me a resulting map showing me the annual hardwood logging residues at 35 miles. I can make that 36 miles, I can make it 60 miles, make it 70 miles. Where we're going with this is we're trying to be able to develop an interactive map so that folks, they can plug in, they can dial up what it is that they're looking for, plug those numbers in, and then it computes a map for them that gives them some sort of an idea of what's going on. Okay, so that's really the point of the gradient model. So in this case, we're seeing where's the best sites for hardwood logging residues at, let's just say, 35 miles. Okay, here's the best sites for softwood logging residues. Red is bad, green is good. Okay, in both these, I can add them together. All right, I can add those 2 miles together, and now where's the best sites for all logging residues? Okay, so you can start developing these really flexible models for folks. Again, you could do it. This is the 50-mile reach. I just plugged in 50 miles instead of 35 miles in that formula. That's what it looks like for hardwood logging residues. This is what it looks like for softwood logging residues. It's a big difference, right? So if I was looking for hardwood logging residues, I'd be focusing in over here. If I was looking for softwood logging residues, I'd be focusing over there. You could also do it for pulpwood. Back up. So this is the pulpwood inventory that's out there. A lot more hardwood pulpwood in the western part of the state. A lot more softwood pulpwood in the eastern part of the state. Do it for agricultural data. There's wheat straw, corn stover, and hay. Again, that's all at 50 mile an hour. And again, if you having trouble visualizing what I'm saying with that is at this point right here, if I go out 50 miles and try to acquire all the hay in that area, that's about, I'd be finding it in this level right about there, okay, based on the annual production. So it's kind of cool way of looking at it. It's not perfect, obviously. There's a lot of errors with it, but it's a really good way of visualizing on a large scale basis. Okay, so that was supply. What about demand? All right, so here's my supply. This is the hardwood chips, whole tree chips, or logging residues, let's just call them, okay, in a statewide basis. Thanks to Helene and back there developing this massive database of what all the demand looks like out there, who all the competitors are. All those maps we were looking at before with all the dots on them, that was from that same database. Each one of them has a wood basket, okay, and they're all may or may not be looking for hardwood logging residues. We modeled that as well. And then it's just simply taking this gross map, subtracting the demand from it, and you end up with a net map. Okay, so if I was again, if I was looking for hardwood logging residues, and I wanted to be far away from the competition, this might be an okay place for me to look. Okay, in the Piedmont of North Carolina. Where are they all going? To the Piedmont of North Carolina? No, they're all going to the coast, right? all these pellet mills. Here's a project that we had done where, just to show you another little flexibility of these gradient maps, is those are rail lines. And we had a client that was interested in going 75 miles out from all the rail lines. And so anywhere along those rail lines, they were interested in maybe putting a facility. But they wanted it on the rail line. Okay, so we went ahead and did that same analysis for them. It's basically that previous map that we were just looking at, but we took the railroads, and all we did is we overlaid those raster cells on top of the rail lines. So at any given point here, let's say that spot right there, that's telling them that they've got about 1 million green tons of hardwood logging residues available on an annual basis, or the potential of that, at a 70-mile radius around that point. Okay, so that enabled them to kind of identify where are the better spots along the rails to put in a plant. Get this to roll. Okay, so the statewide gradient model, where we're moving with this is an interactive online version. Okay, it's supposed to be up and running by the end of this month, we hope. We're keeping our fingers crossed. And we'll let you all know. You'll be the first to know if and when we get it up and running. And we're going to be allowing folks to be able to dial up feedstock mixes and travel distances. And then they'll be able to calculate. Eventually, we're hoping to be able to do a little bit of economic analysis with it as well. Developing strategies with the U.S. Forest Service, the Southern Group of State Foresters would be nice. That's something that we would hope to be able to do, to develop a southern-wide model of this as well. The southern model, I don't know if that ebbs and flows, and I don't know where we are with Bill on that. We were
talking about it.
Yeah.
Stay interested.
Yeah. Okay, so we got a client now, and they're sold on an area. They say, this is great. We really want to move on and get some more specific information. Well, that's when we do the site-specific analysis. We move back from 1 square mile data down to the original form of that land class data set, which is 30 meters. And we start building these travel distance buffers around them. And again, why we do that, if this is a 60-mile radius that the gradient model uses, okay? This is a 60-mile travel distance. There's a huge difference in the amount of wood basket that's actually available at 60 miles compared to drawing a 60-mile radius, okay? It's much more prevalent up in the mountains that, you know, there's a lot of land in that 60-mile radius that is not actually going to be included. So we're way overestimating if we use a radius as opposed to a travel distance. As you get into the Piedmont, where road transportation is a lot easier, it gets closer. We're looking at about 72% of this radius is covered by the actual travel distance. Here, we're actually looking at about 55%. So it greatly reduces the amount of supply area. But we think it provides a better picture as to what's going on. So we build these, we call them our cauliflowers at certain distances. And those are all the travel distances out. We also, because of that wonderful database that Helene's put together for us, we also know what all the competition is. This patchwork clown's pajamas sort of looking map here is just simply all these wood baskets for each of the competitors overlaid on top of each other, okay? So this little tannish cell right there, it might be Weyerhaeuser's need for pulpwood in that particular area, or something like that, okay? Whatever it is that the item of interest that we're trying to model. And, but just because you only see it here doesn't mean that's the only spot it is. It's in here, but it's just being overlapped and underlapped, and it's just a big mess. But what we end up doing is for each one of these areas, we add up what the competition is based on what the industry is. Okay, so each one of those circles we know competition. Each one of these areas we're adding up what the hardwood areas are, what the softwood areas are, and we're able to apply, you know, the county of hardwood acres, or the county hardwood acres inside these particular supply areas. This happens to be the whole 60-mile area. This is just an abbreviated version of the database. That's the hardwood acres inside that county that are inside these particular circles. The proportion of hardwood supply area to the hardwood in the total county area. What we're looking for is how much hardwood do we have as opposed to each one of these counties that we're getting the data from. The, uh-oh. How do we get rid of that thing? Okay. So if I know that, remember, if you go back to originally, our data is all on the county level, okay? Our hardwood residues, logging residues and all that, that's given to us in the county level. So I have a county here, all right? And only a part of it is inside my supply area. What's that proportion I'm trying to find? And that's what this number is giving me, okay? And then I multiply that by the value I'm given by TPO for that county, and it gives me some sort of a proportional value. All right. So we do that for, we add all that up, we get this gross hardwood whole tree chip supply at 10 miles, 20 miles, 30 out. And then we also have the competition, all right, going out, and we just subtract one from the other, and we have a net whole tree chip potential. Okay, for that particular area. That allows us to build these supply curves. This is the gross supply. This is the competition, and we're just subtracting that from this, and that gives us what we're telling the folks is that is the potential of available material on an annual basis free of competition. If somebody has a need for 200,000 green tons a year, this basically tells them how far out they need to, that they probably will have to go in order to get that, to meet that supply, okay? So we give them all these tons of charts and tables and huge reports. We're not only looking at logging residues, like I said, we look at pulpwood that's available out there, tons of other information, and we try to break everything down by tree components to them. This is a pulpwood tree, so we'll try to give them the volume amounts of the pulpwood stick, of the top wood, that's the logging residues. For saw timber, we try to give them the saw timber portion of the saw timber tree. That portion that is actually pulpwood of that saw timber tree, and then the top wood, that would be logging residues and some of these stems and all that. So we're providing them all that information in varying amounts, okay? And we're doing that for 10, 20, 30, 40, 50, 60 miles out, so that they just get an idea on those. So again, you know, we give them we've done any and all of these things for different clients, and we're not going to dwell on all that, but there's just a lot of information that we can provide for them in any one of these detailed reports. Where we're going right now, and we've started doing this with our last couple of analysis, is what about stream buffers? You're not accounting for stream buffers, are you? So we've developed all the stream systems, all the blue line streams in the 5 states, North Carolina and the 4 states surrounding it. And we built stream buffers out to 50 feet around each stream buffer on either side of the stream, so it's a 100-foot stream buffer. And then we modify the volume amounts that we get of the forest land that falls inside those stream buffers and subtract that out so that we end up with even more conservative estimate of what we're telling folks is out there. We're really trying to be able to justify some of the differences that we're seeing between FIA and TPO data, some of the estimates we get for demand and what some of the other folks are out there. We spend a lot of time trying to do that, trying to verify our data and making sure that what we're giving people is the most accurate information that's out there. Trend forecasting, we're starting to do that. We push out about 5 years based on current growth rates, current removal rates, what the demand seems to be in a certain area, and try to give them some sort of an idea. So we've done all these. And this is an October presentation I did, and since then we've already included these 3 things. What we haven't done yet, which is really important, is to be able to provide some sort of sampling error estimates, and FIA provides you with that. We just need to start incorporating that a little bit more in there. That will really scare people. So aside from that, that's if you got questions, we'll just let the team fly up here. Now, Chris is not really a member of Fiber Analytics, but I put his picture up there because he was very important in helping to develop it. But this is our group, and we also happen to be forestry extension as well, for the most part. So I don't know if there's any questions, or you're so dazzled with this methodology that you just don't know what to do with yourselves. Yes, sir.
So this is, to me, a really important step forward in maybe a couple of ways, and I compliment the comment and the question. You know, so the compliment, I think this is really important. The comment would be, as you kind of look at these overlays and really visualize it, and then start to ask these questions, stream buffers. So my question, is that really material in terms of the availability of biomass? So if you look at a 100-mile area, 100-mile radius circle, you know, you've got roads, you've got, you know, all these kinds of things going on. Which are, if you will, the ones that will really swing the answer? You know, so I can envision where stream buffers probably don't matter, power lines probably don't matter in terms of a large footprint. But have you looked at some of those kinds of things?
We can, one of the things that we provide is how much of a difference that makes if you include the stream buffers versus zone. It actually is fairly sizable. It might be for hardwoods on some of these, you know, in the eastern part of the state, most of the streams are surrounded by hardwood stands to a certain extent. And in that case, I'm trying to remember off the top of my head, I've got the data right in there, but it may be as much as 8% difference, which could be considered. Softwoods, eastern part of the state, stream buffers don't mean a thing. You know, it might be 0.1% difference in your volumes, but it was considerable with the you know, and in some, well, it depends on who you're working for, how important that is. If you are working with people who are real sticklers for numbers, you got to tell them, first of all, this stuff is plus or minus 10 to 20% error right off the top, you know, and that's on a good day. You're trying to show good faith estimates. And one other reason why it's important is a lot of the folks we're starting to work with now are going to be answering to environmental regulations. One company in particular is working with the CPET, which is in England, and they're very concerned that this wood's coming off of sustainably managed forest lands. So trying to show them all good faith efforts in accounting and our accountability is very important, I think, and I think that has a lot to do with it.
Follow-up to help answer Steve's question. For North Carolina, it might not be more than 10%. For the state of Washington, when we did it, non-industrial private landowners with the state of Washington's regulatory environment, with the landowners that lost 70% of their acreage. So depending on the regulatory climate, the layout of streams can be extremely steep.
Yeah.
So that would be equivalent to 70% of the potential harvest of the acre is gone.
Yeah. Or modified to some extent.
In that case, gone.
Yeah.
100% gone. So it can be huge.
Is that buffer always going to be 50 feet?
No.
That's a very small buffer.
Yeah.
The buffers in the state of Washington are 272 feet on per side of street.
You can see why 70 gets
one that was
50.
for potential tree height, 270 feet. So it's huge buffers there. 50 feet, not that big. So if you get into a more conservative regulatory environment, maybe a couple states away from North Carolina, it might be much more significant.
The 50-foot was kind of an average. We just tried to simplify it for the person who's actually doing the analysis. And some of the river rules that we have in the eastern part of the state is 30 feet. You get up in the mountains, it could be as much as 150 feet, depending if it's a cold water trout stream and depending on what the slope is going to the stream itself. That determines how much buffer they need to apply. So we just went with 50, covered the whole state with it, called it good, for a first stab, just to see.
And that's specific to woody biomass. Does that entail like other sources of feedstock?
That actually really only affects our pulpwood estimates, to be honest. And so, because we're only saying that pulpwood, the hardwood estimates are there. I mean, TPO says these hardwoods, they've been cut down. This is the logging residues as a result of that. So that's there, you know. But pulpwood, what we're giving them is the inventory of pulpwood, what's out there in order to harvest in the future. And so when we're doing that, we're saying, yeah, there's some pulpwood in these streamside management zones, these buffer zones, but you're only able to get 50% of them. And that's kind of just a knee-jerk what we apply. Dennis may want to speak to that a little bit.
Steve, my answer to part of my answer to your question would be, I think the biggest factors that impact what you can believe in an analysis, not really a question you ask. The question is, who is the future competition that you don't know about? For instance, if you add up all these sources of wood that are in the state that can potentially be used to make energy, ground wood, residues, even mill residues, stuff like that. So certainly under 30 million tons green tons a year, and probably not much more than 20 if you add everything up. So you bring in one more pellet mill that uses 1 million tons plus a year of green material. Think about what that one mill impact is. And of course, they have an impact that is in a radius that's not all that large. So that's one of the big factors when you're doing an analysis for someone. You try and zero in on things like stream side buffers and how tight some of your other estimates are. But you really can't tell them if someone else is going to show up who hasn't started being published before it's broken yet. I think that's a real factor.
Yeah. Okay. That'll do it. Yes, sir.
This model, I mean, the model that you developed, this is a case in North Carolina that, where you've been collecting the data and so on, but this can be applied to any state.
Exactly. Yeah.
In any place. Now, when you are dealing with a point and you talk about 50-mile radius, you might be crossing the border to another state.
Right. Yep.
And the business changes because you have, like, Jim was talking about, that you have a differences.
Different rules.
Different rules and different regulations and so on.
Yeah.
So how you can include that into the model? Can be included. I mean,
We could. Our model's not that sophisticated that we get into that level of detail, analyzing regulations and those sorts of things over state borders. We do have our information, our basic data base covers 5 states. So when we do cross over, we don't just stop at North Carolina's border. We cross over and we, that wood's still available as far as we know. And it does. I mean, that's just a natural fact. We all know that wood crosses state boundaries fairly routinely. So we just apply it as though it was all under the same sort of regulatory system and purchasing and that kind of stuff. But we'll apply buffers at the same level across states and stuff like that too. So, yeah, man.
Well, I was just going to say, if that system can change within the state.
It could. We can get more detailed with that kind of stuff if we want to down the road. If we actually see it as a huge issue. At this point, we haven't really seen. Yeah. Yeah. I think Dan's question was more when you're looking at regulations and stuff like that. And you don't really see that much of a difference, I think, between North Carolina and Virginia in terms of harvest levels. And we're probably more regulated than some of the other states surrounding us, be my guess, in terms of what our BMPs are and everything else. So. Yes, sir.
When you look at the supply part of your study, have you seen anything related to accessibility to the different areas in the borders or the different type of roads, or that's going to maybe affect potential thinking on one side of your 50-mile radius or another one?
We could. We just tend to sum everything up for folks within that region, but we could, just it's pretty easy to do that if somebody was very interested in that kind of information. I mean, for instance, right here, we see the band of, conifers, of softwoods in that area right there. And so, if they were really interested, and we could say, we could probably pick that out and really give them a more detailed analysis of what the conifer or the softwoods look like there, or what the hardwoods look like in that particular area. If that's what you're asking, I don't know if that answered your question or not.
Well, and also talking about the roads, maybe
the roads?
Easier just to get to the hardwoods instead of the softwoods right there.
Oh, yeah.
Maybe a highway going to the hardwoods and not the softwoods.
Yeah, nobody's ever asked us to do that. But, this right here, that little pocket's telling you that's pretty hard to get to. Because in order to get to that spot, for some reason you have to go way out of your way to reach that point. Because that's a 60-mile travel distance to here. And so you can glean where the difficult locations are to reach, and that one of the mountains really bears that out.
Have you considered including haul rate as part of it, not just travel distance?
We could. We can. We haven't done that yet.
We did that for the state of Washington.
Mhm.
And since we go over a road network, we include forest roads.
Yeah.
And haul rates on a forest road
As
versus
a-
a highway
yep.
are significantly different.
Yep.
It does change the picture.
Yeah, it does.
when
You're
you
absolutely
use
right.
haul rate,
Yep.
not just distance.
Yep.
And that would address the mountains are harder to get to certain kinds of
Yeah.
stands. That would pull that in pretty easy.
Mm-hmm. Yeah, that's a good point. Right now, all we're using are stuff that's coming from the ESRI 2007 street maps. And so one interesting thing that you would see is Croton National Forest. We know there's roads all through Croton National Forest, but street maps doesn't recognize them because they're all gated roads. So there's a big gap. So that's poorly addressed. And when you're looking at those sorts of things. So this is just looking at public roads. And okay, yeah, we got a lot we could do with this. That's for sure. It's a lot of stuff to work with, but it's interesting.